Hello, Assalamualaikum everyone, and I welcome you all on behalf of LUMS Data Science Society to our third workshop on data science. And in today's session, we have Rameel Ahmed with us from IBM, and he will conduct this workshop for 2 days, today and tomorrow. So he has scheduled this workshop in this way that for today we will talk about the basics of data science and its hiring process, the entire pipeline of it, and how can you work and secure your job from this position to the hiring process. So every nitty gritty things involved in this entire stream will be talked upon by our experienced fellow Ramil Ahmed. And then in tomorrow's workshop, we will continue from here and we'll move on toward how can you implement visualization via Python on your dataset. So I hope you have been with us in the past workshops, and if you haven't, it's not a issue at all because in this workshop, it's for everyone. So you can be here and take as much learning as possible. And if you have any question, you can write in the chat box so that whenever Ramil would get a chance, he can share and answer that with you all. And by the way, for the previous sessions, if you're interested in watching them, we have uploaded them on our YouTube channel as well. You can go there and visit that as well. And similarly, this session as well will be available there. Let's welcome Ramil. And Ramil, you have the floor now. You can take the session and guide us all in the rich stream and the pipeline of data science.
Hello, hi. Thank you, Numan. Thanks a lot for the introduction. And first of all, I'd like to really just congratulate you guys for a brilliant initiative. I believe this data science community initiative with people coming from the industry and talking about the experience, it will really help you guys. I don't think uh, other universities are doing it in this proper way where there is a proper workshops going on, and apart from the teachers, the people from the industry are coming in. So, and I think it is really important also because what's being taught and what's happening in the industry, there is always a little gap. Our expectations when we are joining a company from after graduation, it's is very different from what we actually see, or to some extent different depending on people to people. So we should know that what kind of things that we are studying will actually help us out, which areas to focus on, and what exactly is data science at the industry level. Is it when I actually joined the industry, many people thought that data science is dot fit, dot train, and dot predict. These are the three commands. What will you work on? Which was a very simplistic idea of what data science is. How it's a much larger picture than that. So today I'm with you guys. I'll be sharing my experience. As you said, I'll be helping you guys with some on how to secure a job at with in the day as a data scientist, and what to expect in the when you're joining a company as a data scientist. What to be careful of as a newbie, as when you join as a fresher from without any industrial experience, of course, after studies. So that is what my focus will be today. uh, j- Let me, so just a bit of an introduction about me. I'm working as a data scientist at IBM for almost 3 years now, and I'm leading a team of five. I'm working mainly on US projects, which are focused on infrastructure services. I'll let you know a bit about it, what they are and what kind of work we are doing. I've previously worked as a junior data scientist at MTBC. It's also an NASDAQ listed American company which operates from Pakistan. It's related to healthcare. So I graduated in 2017 from FAST as a magna cum laude. I have taught data science for 2 years. I've papers published and papers and patents published. After MTBC, I continued as a consultant, apart from working as a data scientist at IBM, as a consultant, healthcare data science consultant. And this one thing is actually something much more interesting because in data science, industry matters a lot. How? Because when you it's much the experience of data science is much different than that of development, of how you develop websites. And because of, and as it is something new, especially for the local industry, what happens is the expectations of the clients are different. They're like, here you have a certain accuracy in data science that you will be wrong maybe 5% of the times. You like, if let's say your accuracy is 95%, the client would see it as, why are you wrong 5% of the time? Is it a bug? Is it what? If they do not actually understand data science. And as it's not a very old concept, the people sitting at the top sometimes have difficulty understanding it. So, and secondly, as once you're looking at the data, you're looking at automation, you're looking at what you can do with the data. You have to look at the whole process. You have to understand the databases. For a developer is given a task that you have to do this, you have to build this kind of a website, this is how it should look, these are the databases, connect with these, that's all. But for automation, you have to do some feature engineering. You have to know what exactly are what exactly are you working on, what will be useful, what not will be useful, how are these features there. So you have to understand the business, you have to understand the data, and then you have to work upon it to build something. So whenever you're working in an industry, you shouldn't, I mean, let's say some of you guys join the telco industry. Now the niche of it, the niche market, now you have moved from the data scientist to something niche, because you have a vast experience of knowing the telecom industry. You know the what are the KPIs over there, you know what are the systems over there, what kind of data is being flown. So that one shouldn't leave. That is why when I left actually MTBZ as a data scientist and joined IBM, uh, I actually received a lot of what can you say, so many projects and many projects as for health related to healthcare, because I had that experience and there are many less people to find at that particular experience. So the industry is really important when it comes to data science. So basically, what is actually data science and how it evolved, and where, how is it different from other fields? What are the different categories? What are the different fields in data science? Because even now you see there are masters being offered, there are degrees being offered of specific to data science degrees. So that means it is being recognized as a science first of all, and then there is something deeper about it, which needs to be understood. Data science is basically and there are multiple roles in it. There you can be a data engineer, a business analyst, data analyst, machine learning engineer, and then at different levels you can be data scientist, associate data scientist, junior data scientist, lead data scientist, principal data scientist. This is the usual flow that happens. People usually in the industry, if you directly, if you were in US or someplace you apply to, you won't directly start from the data science because it's at a higher canvas. It's something deeper. It's taking a look at the overall picture, and it's looking at all of the things, all of the aspects of the pipelines. Whereas what you might start with in as a is maybe data engineer or a machine learning engineer, then moving forward in the career ladder you'll become a data scientist, and then you'll move further from there, from a specific domain of the picture of the industry to looking at more holistic view as you move up the ladder. But here in Pakistan, you can say that we guys are lucky that we are directly offered the title of data scientist, although we are not. At that time when you join, you'll feel that, and as you get to know more about the industry, and especially the international industry, you'll get to know that right now at where you stand, you're not actually data scientist, you're working at a part of it. Data scientist is something much bigger than what you're starting to work at. But it helps you in your CVs and all, that you have a stamp of a data scientist, because you're working in Pakistan. It's a buzzword, people are moving towards it, people want data scientists. So it's good that you get to start from being a data scientist. It's what is data science actually is comprises of these three things, as you can see in the slide: maths, computer science, and business domain expertise. as you know, I just explained that why domain knowledge is much important in data science as compared to any other work that you're doing, which includes development or any other computer science related work you're doing. Domain knowledge is very important when it comes to data science. Combine your knowledge with data science and computer science, domain knowledge and computer science, you have the you can go into database engineers, you can go database managers, database administrators, DBA, handling bigger software, handling enterprise level data which is flowing in, and how to manage that and where to place them. But yet you won't be able to use it to make decisions or to find or make the data talk. You'll be able to manage it, to place it at places at in databases. You will be able to clean it up, you will know how to place it, what technologies to use, what database to use, how fast which DB is. But you have what the next step where the world is now, how do we make that data talk? There are different kinds of data. Obviously all kinds of data are now flowing in the field. I mean, every company does not just have the data in a proper structured way in the databases as forms. They have images, they have videos, they have phone calls, they have sound, they have OCR as one area. I mean, you have to read it from the images. You have to train bots to learn themselves, reinforcement learning, all of those parts, which kind of brings mathematics in. And with the combination of three of these, you get to learn, you bring some new ideas and new things, which includes tools like SPSS, where you do data analysis. And to a certain level, you are able to, see the trend lines, that okay, like if today maybe it's some time series analysis in these are certain examples of some simpler data analysis, that okay, if the price is here today, it will be in 10 days, it looks like the trend is upward. So a simple line can tell you a lot, that okay, after 2 days it might be here. But then comes a bit more of smartness, where you which we will refer as which we refer as machine learning, where you teach the machine how to think, how to make a decision as a human. Let's say, how if this will include how to talk to a bot, how to talk to a human, a bot talking to the human, understanding the human language, and deciding what to do next. A strategic position, I mean, something for strategic plan. Let's say you you're launching a new product. Humans used to look at their historical data, do the analysis using some of their knowledge, apply that knowledge, build a marketing plan. Now there is a computer sitting, give pour in the data to that, and it will tell you which is the best place to market it, what price suits the best. If this is the particular color, it might be more attractive to females. This color historically is more attractive to males, so you can market it this with these particular packages, and a whole marketing plan is ready. So this is where that's machine learning deciding things for you, where when everything of all of these things combine, how the data is coming in, how it is being settled, how it is being used for training, how it is being used to make decisions, what kind of, and it is providing you insights. That whole picture is looked by a data scientist, which starts from the very beginning of the entry of the data to knowledge extraction from the data that is placed. Just placing the data, actually this is how the industry evolved by in the start there were simple statistical techniques around. I mean, in the early 19th century, you saw some Bayes theorem coming in, regression lines, some mathematical techniques to find certain trend lines, or some trend lines mainly, that where the trend is going. And there were actually companies who the data was given, and they used to look at it, analyze it, give it to you after a month, and show and tell you that what's going to happen, where the trend lines are going, what things is working right, what is not working right. And that was more of the analytics part that was happening. In the computer age, you saw uh, obviously neural networks, evolutionary computers, databases, and everything at a much advanced level, and which actually revolutionized to one extent where instead those companies actually had to close up, and people realized, the organization realized that they can do this, some kind of analytics to by themselves also. To certain level they can hire people and do it. Now the next part was, why hire people? That's where now, once they've hired people, why to hire people? What are the things that the machine can replicate? What are the things that the machine can learn? So there comes the new concepts of advanced neural networks and other concepts of data science that teaches, that actually replicates or how a brain learns. Like, how does a brain learn? You read a book for it, let's say for exams, you read books, you take lectures, some things are clicking, some are not, some are conflicting, you're confused about some, you get to learn some things really cool and really well. The whole neural system that's in your brain was actually studied and replicated, that how does it actually work and can machine do it. And the neural networks came into place and different techniques came into place, that given the data, historical records, the right answers to the questions, it's like reading a book for a machine. A machine reads the book, learns that what's being said, what's there in all of these machines, what's there, what are the patterns, what you're solid about, what you're confused about, and then you sit in an exam, and eventually you are uh, finally out and performing it in the real world, whatever you have learned. This is this life cycle of data science also. You train, you test your results, and then you go put it into the real world to implement whatever you have learned. This got developed and the expectations rose high. I mean that now it's like magic. We don't have to hire companies. Decisions can be made through machines. We do not need humans. Let's remove the call centers, Google Assistant. If you see, if you've looked at the IO, Google IO, and all that, they can interact, do the bookings, they can do the sentiment analysis, they can tell you where you are going wrong, they can do your job for you. So let's go to that level. Similarly, at the same time, the speed at which the data was being generated was getting extremely fast and got to the highest level, especially today. I mean, YouTube, Amazon, Netflix, these videos or call records, SMS, everything. In a day, it's more than a zillion byte of data being registered, the new data coming in. Now, how to manage that data and how to make decisions from that data, both of them became a very essential part because the internet became easily available to people, usage increased, and now how to use that data and store that data. That is the evolution of data science, and this is what's happening today in the industry. At IBM, we work at I actually lead a team of 6, which actually works at different countries, which includes mainly US, Dubai, and UAE and Pakistan. And you can see, actually, you can significantly see the difference of thinking and the level of project, or what level people want automation. Here, they're still at the stage. Pakistani industries is still at a stage where the databases or data structures need to be improved so they can capture data at a faster rate. Decisions are to come later, actually, and the automation are to come later. And one other reason for that is cheaper labor available here. So you for which sometimes is actually cheaper than maintaining the machines. So the focus is on this area in countries like Pakistan and India. Then the second level would be UAE, the level at which you can say the Arabs are, or the UAE, Middle East. There are projects uh, which you can say actually replicate the present world, which I explained, that the data is coming in. How the project which I did there was actually related to petrography, that how can we automate oil exploration. I'll come to that. I'll tell a bit of the details about it. How this is because of the demand, the data science field actually gained exposure, degrees, new degrees evolved, new technologies evolved, and actually this is a survey by McKinsey that I mean, it was an old survey that by 2018 US would be facing a shortage of 190,000 workers with analytical skills. Then this other survey from I mean this other survey was actually in 2012, where data scientists, where the chief economist at Google said that the most important job or the hottest job in the next 10 years would be data science, because of this large amount of data being gathered. It needs to be used, it cannot just be sitting, and it needs to be placed in a way that the whole world isn't made a data warehouse with just placing new machines and adding up new data, because you do not want to lose your historical data. So you have to manage all that. So this is where, and it is required in every industry, you name it, and it is that a data scientist is required there, whether it's marketing, whether it's oil and gas, chemical, telecom, banking, everywhere. The data scientists are at the highest demand at this moment. So now coming to the data science itself, how the process of data science, as I've been telling, that it actually differs a lot from a normal process, because you have to manage the expectations. You have to, it's you're replicating a human mind, so you can make a mistake. You have to look at it differently, and sometimes some projects, some data might not tell you anything. I mean, each data would be different. Like for a web, let's say a development project, you have implemented something in one company, you can easily, bring that software package and implement it in the second. Here, the data of the first company is different than the data of the second company. Pardon. So the project that's done in the first place in the first company might not replicate it in the second. Might, there is still a chance you'll still have to do the analysis again for them, and for them you'll have maybe, for one company you might have a 90% accuracy, for the other company you might have around 50-80%, 50 to 60% of an accuracy on the same type of fields, because maybe they're not getting the data right and all. So the process starts with obviously a question that what are the use case, what do you want to do, what kind of problem you want to solve. You get the data out, and then EDA happens. You understand the data, what kind of fields are there. You visualize the data, which we will discuss hopefully in the next session tomorrow. That how do you visualize it, and what are the things that you have to find from that data. And then comes that you have the data. Now you have to model the data on which is the best model which will fit, and then how good it is performing. You have to gauge it, and then the final part is you have to communicate the results. One important part that's missing over here is deploying it, which usually data scientists think that it's just about implementing a model, which I said that earlier. The thinking is that dot fit, dot train, and the model is ready. But how do you deploy it? That's a very important part. Mainly because sometimes, if you guys have worked on data science projects, you would notice that sometimes your prediction takes a lot of time. If you're running on GPUs, it requires a lot of first of all, it requires a GPU, and then if the data is coming very fast, can you deploy it in real time or can you not? You have to decide that. If you can, then you have a certain approach. If you can't, then at what frequency will you run this model? I mean, how would you run it? You can't keep the client waiting, that the end user waiting, that they click a button and your processes are happening, and at the back end they're too slow. They take time because a large amount of data is being pulled in at every minute. So how to manage it, that is also a very important part in data science. You guys must be familiar with agile methodologies and different scrum. There are differences about and scrums that are run in which are used for development purposes. That how do you do the development? What is the development cycle? You take the requirement, you gather the requirements, you divide them into use cases, and then those use cases are then you take build the technology stack, and you define that this part will be done in 2 weeks, this part will be done in another 2 weeks, and at like this at this certain time we'll be done with testing and everything, and a whole developed product will be placed on the shelf or given to you. Here in data science, the flow is actually different. We, instead of following scrum, waterfall methods and all, what is followed is a crisp methodology. uh, have you guys heard of this methodology in what you've been studying, or have you heard of it before, if anyone is?
Nope.
Okay, so crisp is actually, this is the methodology used for the data science projects where you go in. The first thing is you understand business, that how it works, what are the processes. Then you get into the data. You understand which fields are what, where are where is the data placed, how to get that data, what kind of data it is it text, videos, what kind of data is there. Then you prepare the data for your particular problem. That the way you do the EDA at the data understanding and data preparation stage, where you see that what actually is inside the data, how helpful it can be. You do the modeling, and it should be, obviously you should be able to explain your models that how good they are performing, and and you should be able to communicate those models, and that why did you use this particular model. One major problem which I see in interviews also, and uh, in interviews and in resumes also, that people are using really high, just to use those big words like neural network and all. They they have written it in their CV that we have used neural networks for this particular project. The problem with that is the question that I asked them, or majorly is asked, that why did you use this? Why didn't you use a simpler technique? Why didn't you go with that? Do you know the pros and cons of using neural network or not? This is a very important part there. I think especially the people who are graduating in their resumes and all, be careful that whatever techniques that you have mentioned in your resume or in your particular project, you should have the answer of why. You do not need to have the 100% accuracy, but it's important that you should know that why did you use this particular approach. This question is very important when it comes to a data science job, because in other things it's quite clear what the technology stack is decided and you're going to be using those. In When it comes to modeling, there are different techniques available. You have neural networks, random forest, you have naive bayes, and different things for different problems, and different types of data, input data, and depending on the output also, that there are different techniques available. So you should know that while while modeling, why did you use this particular model, and why not any other? If you experimented it with this, then why did you start, what was your thinking process? That's really important when it comes to modeling. Then once your data is modeled, you have prepared it, you have tested it out. The testing part comes in evaluation, which is you have to evaluate your model, and sometimes it's a really hard thing to do, because sometimes accuracy wouldn't work. You guys, have you guys heard of class imbalance problem? Imbalance class problem? Any feedback? Okay, so you guys have heard of it. Okay, so basically, I'll explain what an imbalance class is. That I'll make an example. Let's say in a company, there are out of every 100 employees, three employees leave, three customers, instead of employees, there are 100 out of every 100 employees, 3 leave every day, every month. This is actually called a churn rate. It is a very interesting, it's a very old problem that is being, that people actually that is being followed for basically in telecom, that people are leaving the company and customers are leaving. This is called churn. They're churning, and let's say three of them are churning. Three of the out of three out of 100 are churn. Now you're given a problem that you have given a data of customers, and you are asked that find out how many customers will churn. Now let's say you do nothing and you mark all of them 100 and say that none of them will churn. What is your accuracy? And out of those 100, three churn, three actually churn. So if you talk about accuracy, what is your accuracy? Can anyone type in? Yeah, it's actually 97%. You didn't do anything. You just named all of them 100 people that you 100 of you are not going. And when you will be going to the client and you will be saying, I have a 97% accuracy, if he doesn't understand it, the sensitivity of it, he'll be over the moon. That okay, you've received 97% accuracy, and you won't be lying in any way, because actually the percentage is really low of the people who are leaving. But is this model any useful for the client? Not at all. It's not at all useful for the client. So this is a very major problem. I mean, so that means there was your important class, which you wanted to find out or predict, had a very small proportion, and that was the important one. The other wasn't that important. And your data also majorly, when you will get this kind of a problem, obviously your data would be skewed in one direction towards one particular class. That these people, let's say you mark uh, zero as the people who will stay, and one who are the one who are leaving. You will have 97% of the data would consider of would be the people who are there, and only 3% of your training data would be the people who have left. So when you will be modeling it, those 97% will actually take over. They will be, they will be the one focused, that they will be the one driving the learning part, because majorly you have been learning only that pattern, not the 3% mainly. So because that was too less for your machine. Like you'll have 100,000 records, so 97 multi, if you take the same ratio, how many records of the people who are leaving would you have out of all? So how to deal with that? And second, how to evaluate that model. Now you cannot use accuracy over there. You need have other things for that, which includes precision, recall, F1 score. These are the things you guys might study later on and all, but there are different methods. The point is, the modeling and evaluation gets trickier over here, and these are actually decided once you're starting the project, that what will be the, how will you evaluate your model? How will it be accuracy, or will it not be accuracy, or and it would be something else, because that is very important to be decided initially. And then obviously thinking what kind of a problem you're solving, it will depend on that also. Last part, deployment. As I discussed before, this is also a very important part, that especially if you guys, one other, if you are now completing your, if you're near to, if you are in the senior year and completing your degree, it's a really important part for you also, that when you deploy, well, you should, once you completed your model, make sure that you deploy them someplace, preferably cloud if you can. If not, you should have that deployed models. You should have that for your final projects somewhere deployed. So because that is also a very important experience, and that is something that gives you an edge over other candidates when your CV is being looked at. And you can be asked questions related to that deployment, because it is a very, very important part. Sometimes we develop those models, we do work in our notebooks, but we can only run our notebooks. So someone will give us the data, we'll run it, and then we'll give the results. How will you deploy it? How will the data automatically come in and automatically the machine would work and give it result back, and how will the machine be automatically trained so you can move to the next project. That is when your project is complete. So you should know that what needed for the deployment, and obviously based on how fast the data is coming in, you'll have to define your strategy, how fast you can handle that data. Let's say your model is taking 2 seconds per two 5 seconds a request for each request, and 15 requests come at the same time. Would it be a viable option to deploy that in real time? Would you, or would it be a viable option, or some other option would be required, that your model is working at the back end, data is coming in, it's being processed one by one as it comes forward, and then a response is given to the user that, okay, this is the result. Maybe it's related to imaging, whether it's related to voice or anything. So you have to know that which of the projects can be deployed in real time, and which of them uh, cannot be deployed in real time, and how, and the technology stacks for both of them, if you guys can. That for real time deployment, you'll need this kind of an application, and for non real time deployment, maybe Kafka, or I mean, you'll need some other kind of technology stack. So how would you handle that? This whole process is followed in the when we are making a plan for a data science project, that how much time. It's not based mainly on scrums. It's like, we are at this particular, we are at the business understanding stage, we are at the EDA, exploratory data analysis stage, we are at the modeling stage, and these things happen. And then obviously modeling requires a lot of research also sometimes, depending on the problem. So moving to some of the roles and the requirements of the the day of data, when you're moving towards this data science, uh, moving towards the data science job specification, and towards this side, there are different, as I explained earlier, there are different job roles available, which includes data an analyst, machine learning engineer, data engineer, data scientist. And this is kind of an uh, picture of what how important one role one how important a particular area is compare for these different roles. Like for a data analyst, sorry, tools, programming tools, not just programming tools, other tools like SPSS and all other, these kind of tools are really important. And visualization is really important. He doesn't have too much focus on machine learning, software engineering, and all that deployment cycle and all. You will be, the data analyst will be more at the part of data preparation and data, in this, if I link it to the previous slide, it would be more at the part of data understanding and data preparation. This is the part where a data analyst would work, and also maybe at the business analyst part, in the initial part. Now the machine learning engineer will need to build the models. He requires machine learning. Machine learning in reality, it's good, it's very important for you to know what's the maths behind a uh, particular algorithm, so you can make a particular decision that which algorithm did you use. And for that, that is why I ask you guys that in your, when you are doing your projects, it's really important that you have the answer of why in your mind, that why did you use this particular model. So these modeling techniques, which modeling techniques he'll be modeling it. So he'll be actually doing the machine learning stuff, that fit, train and all. That all part would be done by a machine learning engineer, and he'll fit at the modeling stage, obviously. The data engineer would be the one who would be complementing the machine learning engineer, because he'll be giving the data to him. He will be focusing on cleaning the data, building a data malt where the temporary data will sit in, or where or how the process of the whole data cycle would be. And I mean, not the whole process, but what are the things that would be needed in placing this data and cleaning this data. And some, maybe he'll be managing the Hadoop part, or if it's big data, then obviously he'll be managing those kind of uh, technology stack of basically managing the databases and cleaning up the data. And he kind of sits at the data preparation stage, the data engineer. After modeling, the evaluation and deployment, majorly this is what differentiates a data scientist from the rest of them. A data scientist would be overlooking all of these things, should know all of these sides, and this actually eventually at the data at the deployment level and the evaluation method, that is the person that comes in front, especially visualization, when it comes to visualizing and presenting the results to the client, or doing the initial analysis of the problems of and the decision making part of how the project would be run, and then how it would be deployed. That is the data science. That is the data scientist actually helping all of these areas out, the data analyst, machine learning, data engineer, also interacting with client and having the holistic view of the whole project, and making all these decisions also, that where what is needed, and he should have the ability to be able to jump in and replicate any of these people. So data sciences, that's why I said that in Pakistan we are lucky, I don't know, lucky or unlucky, I don't know that yet, but we directly start from being a data scientist, although usually it does not happen. Data scientist, if you see, if you guys use LinkedIn, and search for data scientist posts in Amazon, or in any bigger companies in the US side, you will see that they require 3 to 4 years of experience if they're hiring a data scientist. Otherwise, they'll be looking for maybe an associate or a machine learning engineer, data engineer, at that particular level, at the initial stages. So that's actually the real whole view of data science, of what these things are. So these are some of the projects, a few examples of the projects that I have been doing, which include sentiment analysis. Here we had a sentiment. This is the easier part. Obviously, this was done for a Pakistani bank where, we had to tackle Roman Urdu also, and it was a really interesting problem because Roman Urdu needed to be captured in sentiment, as it does not have any syntax. Or it doesn't have any particular any particular style, or even this spelling mistakes and all. So that made it a bit interesting, intriguing project which we did. Recommender engines, which I talked about, the marketing plan previously, generating automated marketing plans. Those are the kind of those will be included in recommender engine. Churn prediction, we have discussed. Phone bot, yeah, this is a project that my team is doing with where we are handling voice, which includes voice verification, and we have to go through the research papers and look at those, and see that what kind of technologies to use, what is already there in the industry, and what kind of how to interact and understand it, how to use the assistants, and how to make them better. This is what one part which we are currently working in. Another project that I completed was, this is petrography automation, which is actually for UAE, where where the process is, how do they explore oil? They explore oil by picking up the rocks and taking those microscopic images of the rocks, and based on certain information from those rocks, they used to find out that, okay, where to drill, how deeper to drill, and what to expect, what kind of amount to be expect, and which fossil or which gas, which natural, which of these fuels to expect underneath. So that whole project, they wanted to be automated, and we worked with, obviously, as I told you, business and domain knowledge is really important here. We work with some petrographers in Dubai, world best known pro petrographers, and we were able to automate that process. It was really interesting project, which actually obviously saves a lot of time. Their one image analysis actually costed them around this actually costed them around 300 to $500, and they had around 50 to 60 images a day to handle, and all those images were then automated and converted into that part. So from our service and from what we created computer science knowledge and you work through notebooks, you can actually you have more control over the algorithms. You can tweak them and improve them, and a machine learning engineer would know that. But with the tools, using the tools directly, that reduces your control over the that makes the code more generic for different clients, but does not always provide the best accuracies and does not get you the best results. Bi actually focuses on that business data being managed. It does come under the ambit of data science, yes, but it is very near to data analyst. This is data analyst part and bi part is very near to each other. Data engineer part is more based on more technical than the data analyst and business intelligence part, because the data analyst, the data engineer actually manages these in IBM. The data engineer's job is to manage the Hadoop, the Hive system, and to clear once the pipeline is decided that how the data will flow there, to implement that particular pipeline also. That let's say you have to scrap the data from the internet and then you have to clean it for some kind of problem you're dealing with. So for that, a data engineer, that falls under the aspect of a data engineer, and he does that. Once the data is there, then the modeling part comes in, and a data scientist or machine learning engineer can do that. Business intelligence is the part where you can say the domain knowledge and computer science is required, and tools really help you out in that. It is less technical, and but yes, it also comes under the ambit of umbrella of data science. So moving forward with this, uh, so these are the and after petrography, I would like to explain the infrastructure services. This is mainly the projects that we are doing in America. What is infrastructure services? If you see that, majorly these are this let's say I'll give you an example of Amazon. On Amazon, they have this Black Friday, this Black Friday sale, and every and the end of the month, every end of the year around 25 December and all. At that time, obviously, the load is much higher as compared to the other days. So those machines are actually this. If one machine goes down, and you do not know how they're connected, because it's an enterprise system at a much larger place, and it is spread it all over the world or all over the country and all over US at different places. Different services are running. One service goes down, it is a big problem to first identify which of the services are actually affected. Where are these what are the things that are what are the clients, which are the clients which will be affected, what needs to be corrected. That becomes a big hassle. So infrastructure services is that using the data that the machine is actually generating. Machine usually keep generating the logs. They generate their logs, that the temperature and how long they've been up for, how long they've been working for, and if there are GPUs and all. So they generate all that. That data is being continuously being generated. So based on that, if a machine can automatically make certain decisions, that if there is a if this particular machine is actually at usually slips at a temperature around 90 degrees or 10 15 degrees, so the load should be moved to some other machine for that particular time. So that kind of smartness of how this big enterprise should be dealt with, or where which service is actually running. Sometimes when we are developing the services at this huge level, the services are placed at different areas of the world, and where those services are running and what kind of data they're generating. Getting that kind of data out is actually really difficult, and because it's a very being generated at a very large pace, then different tickets are being opened. Sometimes what we do is we build these modules which automatically open a ticket or a complaint related to a particular service, that it's not working fine based on So it's a preemptive approach. So before the client complaints, we fix those. We know that what's needed to be fixed. So this kind of problems, this kind of automation is done in this infrastructure services project that we handle in Pakistan majorly. IBM Pakistan, basically a major chunk of it handles the infrastructure services for the American companies there. So apart from that, yeah, there's healthcare predict diseases from symptoms and procedures from diseases. This is one of the projects that was done uh, in MTBC. So one other very a beauty of data science is that you can actually you can actually work in a company where, or company of your interest. Let's say someone is very fond of cars. Now the data scientist is needed there also to build these things and make certain decisions and build these automated cars. And here in Pakistan there is a company called AI who actually builds a simulation for testing automated the driverless cars. So you can work on that field if you are interested in politics and economics and you want to work in that kind of a place. You can go to S&P Global. It's a company that's working in it's focused on more on economics and political side. If you're more focused on AI and these AI stuff, artificial intelligence, robotic stuff, these kind of stuff is being dealt at the companies like IBM. They're dealing with it. Similarly, healthcare, if you're interested in healthcare, I mean, there are different projects for that, and you will find one or another company to work of your passion. One of my colleagues was actually very fond of cars. So but his degree, he didn't get into mechanical engineering. His degree was of computer science and he became a data scientist. And then because of his interest, and as domain knowledge is really important, he knew a lot about cars. He was madly in love with cars. He went out and he first worked found out a project inside IBM which was with the BMW. He worked there, and then later on he shifted to working for BMW also for a certain time period. But that the point is that as domain knowledge is important, and you if you're interested in a particular domain, you can actually become a data scientist of that domain, and it will really help you out in your career. So these are the some of the projects and what to expect from data science, and different things that the data scientists do, what kind of processes they follow. From here onwards, I'll be explaining certain things related to hiring and what to consider in your resume, what to expect and how to answer things in the interviews, which is actually, you can say that, and from a not from a generic point of view, but from a specific point of view of a data scientist. I mean, the examples that I'll be giving will be those. And then what kind of things you should consider when you're joining a company and when you're moving out the uh, from the from the from your university. Alongside, yeah, we can discuss what the pay things and all that, what kind of pays are expected, and would how when it comes, we'll discuss those and talk about those. So from here, if anyone has any questions, they can post and post it in the chat. So because right now there will be a bit of a shift uh, towards hiring and resumes and interviews. So for deployment, actually for deployment, there it depends. That's why I said that first you have to see that is your is your product real time, or is your product real time, will reply real time, or will it first gather the data and then reply later on, because it cannot handle it that fast. So based on that, it differs. For instance, like what you usually at a simpler level, for let's say if you guys are implementing it and your base is in Python, you can use Django for front end and Flask at the basic level for deployment at the university level. When it comes obviously outside university, Flask is actually not used for production level, is not a production level tool. Then you can use Gunicon for that, but that is the application server type thing, which will actually deploy the which will actually make it more scalable. When you come in the industry, the deployment will be at a much higher level, which will include uh, the, which will also include cloud, which will also include you can say cloud tools like Kubernetes and scalability, automatic distribution network and all. So that is where you'll be deploying it. And let's say you have to deploy it at the back end, like it's not real time, then you have to cater for, you should look into tools like Apache Kafka. So another question is that how much deployment we need to know. Generally, it's a software engineering thing. So it's a software engineering thing. Usually, when you're deploying the websites and all, there is a part where you have to deploy the models. The model, let's say you have built a model, a neural network model, and it runs on a GPU. It requires a GPU to run, or it requires that kind of a memory to run. Usually that model being deployed, usually the developers aren't able to handle that kind of deployment, that where should they handle the model, because when you, let's say your model is really heavy and it takes a lot of RAM, or it takes a lot of memory, and or it requires the GPU, and a compatibility of the RAM and the GPU, then that kind of deployment you need to know at the very least. If you, not to make the, I'm not saying that you make the front ends and all, it's not needed. The data scientists don't actually go and make the front end, but they should know that whatever model they have built, or whatever technique they have built, how that pipeline is connected, and how is it finally going out to the user. It like the how will it be communicated. And front end doesn't matter, you won't be making front ends, but you would definitely be uh, but you would definitely require some things to deploy, some knowledge that which is the best place to deploy this particular model. So, and how to deploy it, and which databases to connect with, where will it be placed. These kind of things are expected from a data scientist actually. So I hope I answer your question, that to what level deployment we need to know. It's just that the thing that the databases and your models, which is speaking and predicting, where are they deployed, and based, and what's the strategy of deployment. What are the skills to get an internship? Yeah, so I'm actually coming to that part where it's about jobs in data science part, and internships maybe. I'll be coming to that part, and basically I'll also discuss that, how important are actually internships, which people actually look for at these companies, big names on their CVs, and how much they actually learn. So I'll be coming to that part now, if there are no other questions. So so I think let's move forward with the part where I'll discuss some of the hiring process and some things related to data science. So, so the usual process, I mean, this is for almost every company. You guys would obviously might already be, uh, might already have an idea about it, which is you'll submit your resume. Sometimes there is a test about maybe whatever the certain problems being given. The test of data scientists mainly includes scenario problems, and are mainly related to either Python or SQL also. I mean, the questions are actually related to databases and coding perspective in usually Python, but you have a choice in Python, or I mean, there are either online tests, or some companies take the test on paper. On paper, there are, I mean, relatively easier questions which are on the coding perspective, but there are some companies like McKinsey or IBM, they sometimes take IBM sometimes, but McKinsey always take a test through their online portal, where you, even PayPal, they take tests online, which include scenarios, and based on those scenarios you have to answer the questions. Also, there is a coding part. Apart from the coding in Python or the language you choose, the other part is that the other part is SQL databases. They check how you can you link it with databases or not. And one very interesting thing about those tests which are usually online, they also see the optimization, the part that where the deployment again comes in, where and how good you have written your code, and the technique that you have used. Some dynamic programming comes in, where they test it out that can you write fast enough codes, or can you focus on optimization, because that is a really important part in data science. As yeah, these are heavy services that we build, or heavy data heavy analysis that we do. So timing and optimization becomes very important when it comes to data science and projects. Then there are technical interviews, and then an HR interview, mainly about your aptitude, about your attitude, and technical about your aptitude, and all. This is the usual process. So resume in resumes, one should always think about what's their differentiating factor. See, what happens is, we receive a lot of resumes, and let's say our team is hiring, and we ask the HR, or we announce it someplace that share your resumes. We get a huge pile of it. So how do we go through those resumes? Let's say you guys would have a directory, your graduate directory, when you guys would be graduating. So when you are going through a graduation direct, one thing is university, which I think you all of are quite lucky with. And then obviously, if it is GPA, I completely understand that GPA isn't it doesn't actually show how good a data scientist you are, but it shows how good a student you are. But what other factor, if all the CVs are the same, what other factor, how would one, and there are thousands of it. GPA would be one thing that would make the person's life easier to filter it out, or to make a, or to see that which one or to compare at the initial stage. So that is where GPA, it could be a GPA, it could be external courses. Like external courses means courses there are, it would actually differentiate you a lot when you're applying someplace, especially as a as a fresh graduate, which is, you can see courses online which are available freely, which includes cognitive class. You can go to cognitiveclass.ai. There are free courses related to data science. And you can look at Coursera. I mean, if you do not, they're sometimes free also. You can easily get it for free also, but otherwise, those, they're very they have a minute price to them. And those kind of courses, they kind of differentiate you from the rest, especially at this level, because at this level, you are focused more on you are, all of you have done projects, similar projects. If you're mentioning your projects which you have done in the class, they are all the same. So that is not the differentiating factor. Can be an accuracy, that or the technique that you have used to solve them, but that comes later. If that, and that is, if you get lucky and one is able to, one decides to go through the technique that you used. Otherwise, this thing, external courses, would actually catch an eye, because it is something different from the rest of the lot, and not everyone does that at this level. So other is internship. Actually, you do not get much, you do not learn much from it, honestly speaking. I have done two internships before joining. I From before my graduation, one in Oracle and one in Teradata. And those internship, people actually, I mean, unless they offer, the company offer internships or any such intern programs, those are good. But many these companies, which people usually come in as a for internship, there aren't any specific positions. There isn't a proper plan for interns, that this will happen and we are going to do this and all. And so it doesn't really help it in your learning, until and unless there are hiring multiple interns for a particular project. You are asked to come, and you apply a significant time over there. Like, a significant time means at least 3 months you should stay there, then it counts. Because it's actually a period of a project is, for good healthy project, would be around 2 months, 3 months, a quarter actually. So when it is a good time to do an internship, it's, you can say that you don't you think it's unfair to filter out on the basis of GPA? So when it's a good time to do an internship, you should if you're doing an internship, you can do it after the third year. And after the third year, I think it's a good time to do an internship. After the second year, what you can do is you can work with some teacher or some lab. It would be a much healthier experience for you, and it would count more on your CV also, if you have, because we know that, a good learning happens at these kind of labs, because they actually hire students and do something, and we kind of understand the person who is conducting those labs are actually related to someone big in the university. I don't know many names from LUMS or any particular labs over there where you can work with, but there definitely be in our and past in my university there were different labs which like a reveal lab, but which is renowned because of the teacher who headed it. I mean, the professor who headed that lab. So it was quite a helpful experience. That is one thing. That is one thing you can look into. And then at the third year you can do some kind of an internship where you can get an experience of how of a company's environment. And at the third year what you can do is also that you apply for internship at a place which you would like to move forward with, or a company where you can move forward with, so you can make connections and all. The technical learning is less, but you get an idea of the environment, which actually counts. So if you get into, let's say you get an internship in uh, some company, let's say a telecom, let's say Jazz, Telenor and all, and you work there for 3 months, you get to meet people, you get to know people, you get to understand the environment. You do not learn much technically, but you have a better chance of understanding the environment and getting and being connected to people and getting a better chance. The other question is, don't you think it's unfair to filter out on basis of GPA? Like in some universities, it's very, yeah, you're right. You're right. So people actually know about the universities also, right? I mean, it's not, I've mentioned GPA just thinking that, all of you guys are from LUMS, but yes, it's, it's actually university and then the GPA. And I said it earlier also that GPA is not the right way to filter it out. But how do you think one would go through, let's say I right now at the I come to LUMS and I ask for a directory, and I have a whole book of 2000 pages. As a lead, I do not have time to filter those to go through all of the CVs. I might ask the HR to go through them and give me certain people who are good, and then from there I can take it up. But HR doesn't know what's needed in a data scientist. I mean, at a general level, he would know that, okay, a data scientist need these things, but he wouldn't know what kind of courses is good, or if all the projects are the same for a newbie. So because after being a newbie, obviously you'll have an experience which will actually count. So but being a fresh graduate, you guys have the same record mainly. Yes, university matters. GPA in filtering, it's a reality, it shouldn't be this way, but it matters. Unless, yes, you have, that is why I'm saying a differentiating factor. Some people might go through all the GPA or all the CVs, but I'm telling you what in reality happens, that you get a lot of CVs, you have to filter them out. You can't call 1,000, 100, 1,000 or 2,000 people for interviews. So there you have to filter them out. So, and there is something on basis of something you have to do it. GPA is one of them. That is why I said, if someone does not have a good GPA, he can find any other differentiating factor. That can be an external course, it can be an internship, also it can be any other project other than the coursework. You have done some other project with someone, or along with someone, that would count. A research paper would count if you have a uh, if you have that uh, I mean, if you have written a research paper, that would obviously count as a very big differentiating factor. And then obviously project which is extremely relevant to the company. This actually happens if you can mention it in an internship, that you did an internship with this particular project, and that time it can be very relevant. uh, so might be someone in good DS techniques but not in non-programming courses. So isn't it unfair with no, it's, I mean, I'm saying that GPA is one of the factors. If you're not if you do not have a GPA, then you have to, how would one know that you have a good aptitude for data science techniques? You need to put something on your resume. I mean, in reality, what should happen is maybe all of them should be called for interview, but you need something, but it does not happen that way. Many companies use ATS to filter out candidates. How to make your resume that could get past ATS? Also, please share more about opportunities at IBM. Can you write down the full form of ATS? Because in IBM or before where I've been working, we didn't use ATS, I believe. This is what happens actually. This what we do is we get the CVs. It's in IBM we get the CVs from the HR or through people, in the team they give us CVs, or through the HR, and HR advertises the post and we get the CVs from there. Uh, so application tracking system. Okay, so application tracking system, you can get, I mean, it's just basic information there. You get some basic information, which is the years number of experience you have and all. It actually helps you, that application tracking system actually helps you, find out, are you do you actually do you actually cover all the basic requirement for this particular job or not. That does not, that is not that, if you cover all those requirements, like let's say 2 years experience is asked, you have 5 years of experience, or your GPA is asked, and there is a certain, a very high level of GPA, that, I mean, it will uh, it might, filter you out to certain extent, but otherwise it's just for minimum requirements. People usually go through CVs because they know that ATS system isn't that good. It's for your application being registered, and your application being registered, and at the minimal, yeah, it's looking at, do you fit the minimum requirements that are needed. Maybe, yeah, some other companies might have something advanced, or at a outside they might have something advanced on what technologies you've worked on, and fetch information like that out, and based on that. But I don't think it's at a level, the advancement is at a level where one can only depend on ATS for filtering out the candidates. Usually it is some kind of, the resume is needed. And yeah, in resumes, people, what they make a big mistake is they mention technology they do not know well. They just said they've just heard the name of it, or it's a buzzword just to get in. They use those names, and then what happens is you're caught at the interview and you move nowhere. So that kind of a stunt doesn't help you out at all. So make sure that whatever you are mentioning in your resume, write those things down, which high in a highlighted way, which at a highlighted place, which you are really good at. Later on comes the things that you're shaky about, and be open about it, that you might not know that much about them. But because your interviewer usually will ask you the questions from your resume, he might ask you about a project that you have done and your thought process over it, and the questions that I said, that why did you use this kind of a technology and all. So that is, and if you said, if you have claimed that this technology, he'll get a deeper dive at it, that how much do you know about it. So be careful when you're writing big names in your CV, because you should be sure that you know them really good, and you're not just writing them just to get past a particular phase. Because because the interviewer wouldn't usually, now it's not like they'll be asking you job specific questions. You're a fresh graduate, you do not have the experience yet, you have not shown your all capabilities yet. So they'll be asking you questions from your resume. So be careful what you write about, what are the technologies you mention in your resume. Be careful about them. So this is about your resume. I think differentiating factor, you all should think, all, especially the ones who are graduating, should think about what differentiates them from the rest of them, and how they can highlight it in their resume. Now, the next part is a few relevant interview tips, opportunities that I'll discuss those at the end. So a few relevant opportunity, interview tips. These are obviously your confidence, which you get a lot in LUMS graduates, but not overconfidence. Just be careful about that. And that's something that could be, that obviously counts in your body language and how you sit and how you talk, that matters. And yeah, in somewhat a very common mistake is that in a technical interview you're asked a question, and because it is not going well, you decide that you decide to guess answers, which makes it worse. So if you do not know something and you're there confidently, just admit it that you do not know about it. You can say that I do not know about it, I can look into it and I can learn, I can look into it, or I can look into this technology and get back to you, something like that. And that is really important. So avoid guessing, then drive the topic of conversation through your towards your strengths. Yes, so first thing is that would help you is the resume and the projects you have mentioned on your resume. Then the other thing is that uh, when you're talking, just if you feel that the conversation is being slided into a place which is not your pitch, or it's not where you want to play, just talk it out, talk your way out to something which kind of brings back to your topic. So like your strengths, or oh, I haven't worked on this particular technology, but I have seen similar technology like this one, and I know a bit about it, I used it in this particular project. And now you're back at the track where where you brought that conversation to your strengths, instead of just saying no, I don't know about this technology. That you stop there, he'll find a new pitch to play with, the interviewer. So instead of that, you can slide it back to what you know, to a certain level, and have a good conversation with the person. And yes, if you there are some those trick questions and there's analytical questions where in the start, usually at the technical interview, they're even asked at IBM also that three you have those three bowls and you have to pour the water and all those kind of questions and all. Just show your interest, just give up your best shot. You should be thinking, you should don't have to be right, but you should be thinking. And it gives a good impression if you ask that what how it I mean, what was the answer? And we might already know that they'll say that you can go look into it, but it's good to ask. It shows a good attitude. Then interview is not over. Yeah, sometimes what happens is when they say that you have any questions or something, the interview you still have a chance to impress over there too, by your questions, that about by showing your interest, by if your interview has went bad, you can just say that these were the topics I wasn't prepared for. So if you give me 1 or 2 day, I can actually get prepared for these and can answer these questions. I mean, putting it out doesn't hurt, especially as a fresh graduate. And second, you should ask questions which actually shows your interest. And one thing is, you should already be interested in these things, that what are the projects you guys are working on, what kind of technologies do you use, which region is your project based in, what should I be expecting if I get a chance, what can I expect from a job, not a salary point of view, just what kind of work, show your interest. And that kind of just remove your whole image. If the interview has been bad, it might just your passion for the field or your interest in the job might actually save you from getting rejected. So that's a small hack for it. If you get that's what I said, if you get stuck on a topic, ask for time, like I can reply, I don't know this technology, if you give me a day, I can look into it and answer this question. This kind of a thing really help. And yes, research a bit about the company before the interview. So I learned that from experience. It was a, I mean, kind of a bad one for me. I was in the second phase of IBM interview, and the guy actually just asked me, okay, so what do you know about IBM? What does IBM stands for? For me, IBM was always IBM, so a huge behemoth. But I never went into the details of what IBM actually stands for, and I had a busy day before, and I wasn't able to look into it, and that was quite embarrassing because IBM actually stands for just International Business Machines, nothing more than that. So but I mean, I got lucky there, but that was a close call. So research a bit about the company, and if you have the names of the people taking your interview, look at them, maybe their LinkedIn profile, have a you'd get to know what level of interview you'd be expecting. So research that about. Then yeah, eventually, if you're into I mean, interviewer will usually ask you that what do you expect, what is your expectation, salary expectation and all. A good thing is to avoid this kind of a question as much as you can, but if you have to answer, do not go with a preset mindset. Go answer that question based on how your interview have went. You would have a good idea about it. You have to just apply some data science in your mind, and based on different features you'll have an idea of how your interview went, and what kind of an expectation you should actually ask for at this time, and how you can avoid that and all. So that is these are a few tips for the interviews. Um Anything, you guys, any questions, any further questions right now? There is just one other small topic that I'll cover right now uh, is that what should you be looking at when you're applying it in a company. So I'll be moving towards that next. So if you guys have any questions till now, let me know. So yeah, so moving forward, what to look for as a fresh graduate, basically when you're in your open house, or when you're applying for the company, we are actually more looking forward towards what will be the pay. And it's kind of an internal competition also, an unsaid competition also, that between us, our friends and all, that what kind of pay we are landing a job with and all. So uh, so that is so one at this stage, actually it's, I mean, easier said than done, but one shouldn't be focused too much on the pay. You have many bigger things to think of, because I've seen people going at a very higher pay, but as soon but they were given all kind of work, and then they just had to move out, either because of the work pressure, work environment, or they were moved out uh, because the company actually couldn't afford them anymore. It was a startup. The startup usually pay well, and they, and on open houses they're advertising themselves as the big guns, and I mean, office in Silicon Valley and all. It's a small office. Everything is being run from here, and they can change their mind anytime. So you should be focused on the organization that you're working on, type of project that you are working on, because after fresh graduate, it is very, your learning period has not stopped. It's actually a new kind of learning which has just started. So you should know the project that you're going to be working on. uh, what type of project that you're working on, like the team is working on, or the company works on, what kind of projects are those. You should know those. You should also, a very important factor at this time, at this stage after graduation, is uh, about the team and the lead you're going to work with. If it's a startup, you should look at the person who's at the top, or who will be there. Like many of the startups here, they have some good they hire some good professors at the principal level, at the higher level, and they're really good, and you get to learn a lot from them. So those kind of, if it's a startup, if it's a startup, do look at those, that what are the people you're going to be working with, and who will be your leads. You can look into their profile, and it will actually, these are the things that are very important, because your aptitude and how to think will actually depend on these things. Sometimes what happens is that people join these they're the people join these huge companies, and there's very limited work there. In the initial days, they're really happy that they're getting paid, but there isn't much work. And eventually, after a few years, they realize that they wish that they kind of have done something, so the learning process wouldn't have stopped. They could have applied to other places and all. So that happens in this kind of in these corporations. And in startups, I told you that the pays are although really high, and they attract you through their pays, but you have to see that what kind of office environment do they offer, who is the lead, what's the vision, I mean, who are you going to work with. Because at this stage, the person you're going to work with plays a very important role. Like, I, without doing a master's, was able to write research papers, publish patents, because I initially worked with one of my professors in a company. He was a consultant, and it really helped me, focus on both the things, working on the real world projects, and also develop something that how can I convert this into a research, and how could I convert this into papers, and what are the, and I get to see that world also. And obviously data science is something very new. Machine learning, data science, these are, people use it as buzzwords, and uh, they hire, they hire you guys, and they hire us, and then the projects aren't those. The projects are for different nature, which shouldn't be the case. So you should ask about the projects, that which project you're going to be working on. Just so you're a good resource, they hire you saying you're as a data scientist position, and then the work is totally something else, which will be unfair, and it wouldn't help your resume, or it wouldn't be much counted in your CV if you're applying for a senior role later on, later in life. So you should know those things. And alongside, what are the, you, this is a question you should ask, if at the HR level interview, if all is went well and all, that what are the learning opportunities, what kind of courses can I do, what kind, is there any course you guys can, I mean, offer and all. I mean, there's some companies you don't have to ask, like IBM and all, at this, at that level, because they already offer a lot of those courses. They have a whole learning platforms and all. But it's always good to ask these with other companies, that how will you be learning, what will you be, if you want to do a particular course, or how will your learning be going from there. Because if it stops, you stop actually. And you have to learn. So and these are much more important things than the pay. The pay, because I told you, there were friends who joined a company with higher pays, usually startups. They were working actually 12 hours a day, 6 days a week, and not moving forward anywhere also. So they were quite frustrated. And some, and in other, they had huge cuts due to COVID, or the company, before even COVID, the company decided to wrap up. So those kind of troubles are there, and or just a little bit of pressure on them, and they start to downsize. So you have to be careful. You have to look at all those aspects when you're joining that company. So similarly, so much more than the pay, because the thing that startup have, which attracts, is the pay. Actually, they will actually give you a better style, better package than rest of them. To differentiate, if they're giving the same package as the rest of them, then they must have something unique with them, which might be the team and lead, because that actually, and the work that they are doing, because that also actually matters. So these are the things, be careful about. uh, One, when you are joining a company, or when you are actually looking to go to a company, what kind of external projects can we do. There are actually many opportunities for at the university level. I don't know, are there labs in, there must be labs in LUMS. However, we had in fast, actually we had the different labs. Projects were going on in the summers, and we could jump in and join. And external projects could be, you can find one. I mean, can be referred to some places, or maybe a freelance project you can do at a certain level. Or yeah, Kaggle projects are more useful. Kaggle they're actually competitions. Their projects, they, I mean, how do you do not, if you're working with a team doing a Kaggle competition, that is great. Alone you're doing a Kaggle competition, you'll get to understand the problem, but it's not that helpful when it comes to learning, honestly. Because you should, when it comes to external project, you should look at the team environment also. You should work with someone. But honestly, we think that we know a lot when we graduate, but after a year or so, you'll realize that we know very little, and there is a whole huge ocean out there to learn. So it's, and that ocean can be shown to you by your lead, by the person you, or the team you're working with. So look at those projects with certain teachers, if you have, or certain professors. Kaggle, obviously, that could also help if you can get a good score somewhere. You can stand somewhere on it, or the project itself is really interesting. Yeah, that is one different factor. Like one project, a project I did in the university was, um, I picked up this X-ray related project, which actually through X-ray we generated sentences or X-ray reports. So there was a whole neural network cycle, two neural networks, CNN and LSTM involved, and we connected them, and through the image we generated the reports. So that kind of a project at this level, where where it's a good level, where you do not, where the accuracy actually doesn't matter that much, but the project itself is really heavy. You can do that, but most, I think, you get time in summers, or if before summers, you can discuss this with your professors. They usually have projects with them. They can guide you better on what kind of projects are there available, and they can be a great differentiating factor when it comes to your resume. So any other questions? Okay, thank you, Alamgir. So if there are no other questions, we can end the session. And as per the IBM opportunities at IBM, uh, what you guys can do is, I think, I don't know if you're graduating or graduated. One of the things is that if you're graduated or about to graduate in this month or something, which I think is less likely, you can share your resume with me. We I mean, my team and we are usually looking for people, and we hire at Lahore, Islamabad and Karachi. And apart from that, once you what we once you're graduated, then yes, obviously IBM actually comes to LUMS also. And uh, we we have we pick we also select people, and look, we come to the open houses, I believe. If not, then you guys can contact me. I can arrange something there in LUMS, which through which hiring drive or something. Although I think usually we are contacted by LUMS, and we are there interviewing and meeting people and all. So those are we have a brighter blue program, a graduate for fresh grads. And it's a program which actually is for 2 years. You get to learn, you are a part of IBM, and you get to learn the technologies, different clients and all. You have a good learning experience, and after 2 years you're solidly a part of IBM, like at a proper job role. Before that, it's a whole brighter. This is called the brighter blue program, where you guys can hit if after once you after your graduation. And it's a really interesting program. You get to know a lot about IBM and clients and what to expect and what not. So that's the opportunities about IBM. If anyone is available for job at this particular moment, in at this particular month, I would say in February or March, they can definitely contact me anytime. And for any other guidance, any other thing, you can contact me on LinkedIn. And that's about it. Anything, Numan, are you there? I'd like you to take over the call and end it.
Okay, so thank you so much, Ramil, for the session. I was here throughout, and like I couldn't take off my seat even for a second, because everything that you were saying was so related um, towards the field, especially as a graduating senior. I know the importance of all of these things, and especially we are all required to have knowledge of these things, especially when you mentioned regarding internship and projects and research papers as well. So thank you so much for Ramil for everything and that you mentioned. And for the participants, I would like to say that you can contact Ramil as I mentioned on his LinkedIn account as well. And from there, I think it's the best way um, and most convenient method as well. Thank you so much, Ramil, for today's session. And inshallah, we will meet again tomorrow for with further insight, and we'll see how can we implement data visualization with Python in our daily life projects. So thank you so much, everyone, for joining. Take care, and we will end this session over here. So take care and Allah Hafiz.